Now data science is again like an iterative process, and if I have to explain this particular diagram, it will take at least 1 hour to discuss this particular diagram itself. But understand this thing, it's basically starting from the very beginning. We have we are acquiring data, and we are understanding. So there is a business understanding. So domain knowledge is very important when it comes to data science. You are acquiring the data, and you are acquiring data from different sources. So in an enterprise environment, you will find there are like hundreds of systems and hundreds of different sources, and these sources can be giving you structured data, unstructured data, semi-structured data, or these sources can be batch sources or near real-time sources or real-time sources. So there can be multiple sources in different shape and form. They will give you the data, and sometimes it's not so easy, and a lot of times, I will say a lot of times, it's not easy to acquire the data from external systems. So sometimes these systems will expose API, this application programming interface, it will expose, or you have to basically fetch it at the database level. So there can be different ways through which you can acquire data from the data source. So this data acquisition takes time, and you are actually acquiring data and then building your data lake. So I'm talking about big data science. So when you are fetching the data, you are gathering the data, you are putting it into data lake, and in the data lake, you will be performing the data cleansing activities. You will be performing deduplication of data. You will be ensuring the data is consistent to the standards, and you will be doing 10 other steps. Like a lot of steps are actually involved. For the timing, just understand you are acquiring the data. And after that, you are modeling the data. So this modeling, you can see there is a step called feature engineering. So in feature engineering, you are ensuring that before you give input to the model, the inputs are consumable by the model. So, what is a model? Model is basically machine learning. It's representing a real world entity. Modeling means you are representing a real world entity, and that model is responsible for predicting something in future, right? So this model is basically in getting inputs, and these inputs are this input is actually data, and this data we have to do a lot of cleansing. We have to do feature engineering. We will not throw data like that to our model. If we throw like that, then what will happen? It will take more CPU cycles, GPU cycles to actually compute or understand like what exactly you are trying to do. So it's like training a kid. Look, when we say we are training a machine learning model, so it's like teaching a kid. When you are teaching a kid, if you are showing complex things to the kid, then kid will be confused. I will give you one very simple example. If you show timestamps to your model, then your kid will your kid or model. So basically, you are teaching a kid, and you are saying that these are the timestamps on which at which frauds happen, right? So your kid will be confused, like what is a pattern in the data. But if you remove timestamp, if you transform these timestamps, and if you remove the time part, and you just extract maybe day of the week or time of the day, or you extract the important information from the timestamp and you give that as an input to the machine learning model, then it will be easier, right? So if you show a number between 1 to 24, which is like hour of the day, then it is easier for your kid to understand like what you are trying to communicate. If you are showing timestamp to your model or to your kid, then it is very difficult for anyone to understand like what you are trying to communicate. This feature engineering is like you are just ensuring that you are transforming your data, cleansing your data, and then you are making it useful for machine learning model to consume it, right? So this is fine. After that, you are training your model. When you are training your model, your model is understanding and identifying pattern in the data, and then it is basically evaluated, and you are basically understanding like whether the model will perform good in the production or not. So before it is deployed in production, you are evaluating, you are testing your model, you are taking a quiz. You are taking a quiz of your kid, and you are checking whether your kid got it or not. If there is one concept called memorization. Memorization is like ratta laga dena, right? So this is like if you are basically memorizing, your kid is memorizing, your machine learning model is memorizing, then it is not good. because you want your machine learning model should generalize, right? So generalize means like it should basically be able to identify the pattern. For example, when I'm uploading my picture and I am wearing a cap, then Facebook machine learning model is able to identify this is a picture of Bhavuk. But if I am not wearing a cap, then it is not saying it is Bhavuk. So that means it has memorized and memorized noise, and it has memorized if someone is wearing a cap, then that person may be a Bhavuk, right? So this is not a good pattern to identify. So your machine learning model should generalize and it should identify the actual pattern in the data rather than learning the noise, right? So that's why we have this model evaluation and understanding whether the model is working fine or not. And then finally, we will deploy that model in production. And this particular model will be serving maybe Amazon recommendations. You get so many, you get recommendations for your friends also on Facebook, like who should be your next friend on Facebook, or you might know the people. So these things are actually coming from machine learning, and these are basically models deployed by Facebook, Amazon, Google, different like vendors. And these models are actually predicting like which person you will like. There are billions of people on Facebook, and it is able to identify only those people who are your friend, right? So that is beauty. And even in Amazon also, there are so many products, like there are millions of products on Amazon, but Amazon knows that which product you will like. Even we don't know like which product we will like, but Amazon knows our liking, disliking, and based on that, it is recommending the next product that we should buy, next book that we should buy, right? So that's the beauty of using machine learning. It is able to work on big data sets, and it is able to identify these things very easily. And it is basically helping us to make decisions.